Hello, welcome to this video. In this video, let us take a problem on dual cycle. Now, let us start reading the problem. An oil engine working on a dual combustion cycle. Now, it is also called as limited pressure cycle. So, either the problem will be given as dual combustion cycle or limited pressure cycle. So, because if you compare it to diesel cycle, we have heat is added at some part of the stroke in the constant pressure. That is why it is also called as limited pressure cycle. So, the moment we see that it is a dual combustion cycle, what we can do is that we can write PV and TS diagram. So, it will carry weightage for the marks. So, what we will do is we will write PV and TS diagram of a dual cycle. So, pressure versus volume, reversible adiabatic compression. Okay. So, then constant volume heat addition for some part of the stroke, constant pressure heat addition for some part of the stroke, okay, constant pressure, then again reversible adiabatic expansion, then we have constant volume, we will have constant volume heat rejection. So, 1 to 2, 2 to 3, 3 to 4 and 4 to 5 and cycle is completed by 5 to 1. So, this PV power gamma is equal to constant, volume constant heat addition, pressure constant heat addition, reversible adiabatic expansion, then volume constant heat rejection. So, heat is added in two parts, one is here QS1, you can call it as QS2, alright. So, the total heat will be QS1 plus QS2. Similarly, the same thing can be written in TS diagram. So, first process is compression, so entropy constant, reversible adiabatic or entropy constant, then constant volume heat addition, then constant pressure heat addition, constant volume heat addition, constant pressure heat addition, then again 4 to 1, 4 to 5 is reversible adiabatic, then we will be back from 5 to 1. So, this will be again volume constant heat rejection. So, here if you show this will be QR and this will be QS1 and this will be QS2. Okay. So, this is what is the cycle. Okay. So, now the moment I see that this is a dual combustion cycle, I just wrote PV and TS diagram. Now, what has been given to us, compression ratio is 14. So, let us write the data. Compression ratio is given as 14 and explosion ratio is beta. So, explosion ratio obtained from indicator diagram is 1.4. So, beta is equal to 1.4 and if the cutoff occurs 6% of the stroke, remember this we have written in diesel cycle also. So, cutoff is V4 minus V3 here. So, do not mug up, cutoff is happening here, alright. So, V4 minus V3 is 6 percentage. So, that is 6 by 100, 6 percentage of the stroke. Now, stroke will be V1 minus V2. Okay. So, then we have been asked to calculate what is the efficiency. Okay. Now, we know that V3 is equal to V2. Let us take this common here, V3 common here in this expression. We will have V4 by V3. So, this will be 1. This is equal to 0.06. We can take V2 common here. So, V1 by V2 here minus 1. Okay. So, then V4 by V3 is what? Cutoff ratio rho, because V4 by V3 is rho, cutoff ratio, And we also know that V1 by V2 is equal to compression ratio R. And we also know that we can cancel this V3 is equal to V2 because between process 2 and 3 volume is constant. So, this can be cancelled out. Okay. Now, this will be rho minus 1 is equal to 0.06. Now, this will be R minus 1. Now, we can calculate the only unknown is the equation that will be true. Okay. So, we know that this is 0.06. R is known to us, that is 14 minus 1. This will be rho minus 1. Now, let us solve this equation. Alpha x minus 1, alpha equals 0.06 into 14 minus 1. So, let us go for shift. Solve for x is equal to 0. We will have 1.78. The value of cutoff ratio here is rho is equal to 1.78. Okay. So, now we have got the cutoff ratio, compression ratio and explosion ratio beta. So, these are the values which we need in order to calculate the efficiency. Now, we know the efficiency equation for a dual cycle is given by this expression. Okay. Now, let us substitute everything here. We must be able to calculate the efficiency. Okay. Now, efficiency is equal to 1 minus 1 by now R is what? 14 power gamma minus 1. Gamma we know, we must know. Gamma for air is 1.4. Gamma for air is 1.4. So, therefore, this will be 1.4 minus 1. I can write 0.4 directly, 1.4 minus 1. Then beta is 1.4. Then rho is 1.78. Power gamma, so that will be 1.4 minus 1. Okay. So, then this will be have to be multiplied for whole thing. So, total bracket beta is 1.4 minus 1 plus again beta is 1.4, gamma is also 1.4 multiplied by rho, rho is 1.78 minus. Okay. So, let us keep it simple before we move on. 1 minus 1 by 14 power 0.4. Okay. So, this will be, I will keep it as it is. This has to be done in calculator. And this portion I am just saying that 1.4 minus 1 we can write it as 0.4 plus 1.4 into 1.4 into 0.78. So, now we will solve this in calculator. Okay. So, 1 minus numerator 1.4 into 1.78 power 1.4 minus 1. Okay, that is the numerator. Let us come to denominator. 14 power 0.4 multiplied by 0.4 plus, so 1.4 into 1.4 into 0.78. So, that is 61.42, that is 0.6142, which has to be multiplied by 100 to keep it in percentage. So, efficiency of this engine is 61.42%. Efficiency of this engine which is working with dual cycle with the given cutoff ratio, explosion ratio and compression ratio comes out to be 61.42%. Okay. Thank you.